here. And so there's a force this way. And then the mechanics of the boat, which we can talk about separately if you're interested in after class. The mechanics of the boat, and that makes that go forward. Now, for the airplane wing, if you come along like this, if I go like this, okay. So if your airplane wing looks like that, airplane stalls and crashes. Why? Because the air can't flow around the back of it. Now, if the airplane wing is pointed straight at the wind, just flapping around and doesn't do anything either. So the idea is you can't have an airplane wing, you can't have this wing pointed straight into the wind, especially the modern airplane wings where there's not much curvature on the top. You can't have the wing too steep. If the plane tries to climb too fast, it'll stall. There is an optimal position for the wing. Now, fortunately, with the plane, if it stalls, you crash and die. But with the boat, if it stalls, it just stops going. So there's no harm to it except embarrassment. And if you stop going, you also lose control of the boat. That's when people are most likely to run aground or to get blown under the bridge or something like that. So we're going to learn how to adjust the sail to its optimum efficiency. And the name for that angle of maximum efficiency is verge of a luff. Luffing of the sail just flapping around, not doing it. So in this boat example, the wind's coming from the top going downward. If the sail is pointed right into the wind, it's going to just flap around, nothing. If the sail starts presenting an angle to the wind, then the wind will fill the sail and it'll start generating power. If I increase the angle even more, then it becomes less efficient and it actually loses power. Now it seems strange because the wind's blowing straight at the sail. But what you're losing is you get the push here, the full push of the wind, but there's no pull from here. In fact, instead of having pull from that side, you have to squeeze all that air out of the way. You cannot go faster than the wind, for example, if your sail's like this. And this is the way square riggers used to work, the old-fashioned boats. The wind would push on one side, there's no pull on the other side. So there are two disadvantages. One, you can only go more or less in the direction of the wind. So if the wind's blowing in this direction, the old square rigger boats, you go here, you go here, you go here, you can never go back. And the other disadvantage is because you're not using that airfoil effect of the sail, you can't sail faster than the wind. You can't sail nearly as fast as you can now with our boats. So the way to find that point of maximum efficiency is, let's say we're in a close call. So point 45 degrees into the wind. If I let the sail all the way out, it's nothing. To start cooling the sail, it'll stop nothing. And right at that point, when it first stops nothing, that's called verge of a luff, and that's maximum efficiency. Pull it in anymore and start slowing down. So technically, it does look like this, about 15 degrees or so. But you can't really judge 15 degrees very easily. It's hard enough just to judge when the wind's coming at 45 degrees. So the way you do it is you let the sail all the way out. Then you pull in the main sheet. That's the rope that attaches to the main sail. And pull in the main sheet until the sail stops buffing and And just at that point, that's maximum efficiency. That's verge of a line. Now, any questions about that? If I am here, I'm going to close all. And which side is the wind hitting? Port side. So the sail is going to be here on the starboard side. If I want to stop, let the sail go until it ups. The wind's coming from here. Pull it until it stops moving. Verge of a loft, maximum efficiency. Now, it happens that you'll see this wing go outside, but there's a triangle when you look straight back. A triangle in the main sheet in the row. When that triangle is a right triangle, that tells you also that you are at the verge of a loft. So the reason that's important is that it's actually kind of hard to tell when the sail stops lofting. It's a very gradual transition. So when you're sailing and you want to find whether you're at the verge of a loft, we're going to learn a few tricks. First, a couple of other terms. If we want to turn from here to here, there's a term for that, bearing off. So when you're turning away from the wind, we call that bearing off. And when you're turning toward the wind, we call that heading up. We're going to use these terms once we start talking about how to sail efficiently. It's very hard to figure out what to do with the tiller and translate that into what direction the boat's going to go in, and then translate that into, well, how is that going to affect my direction with respect to the wind? So the best thing to do when starting is just to memorize. You bear off, pull the tiller away from the sail, just like coming off the sail, head up, push the tiller toward the sail. So if I want to go from here to here, what do I have to do with the tiller? Away from the sail. Tiller away from the sail. And from here to here, tiller toward the sail. So let's move on to how to sail upwind. And when we sail upwind, we'll be using one of the close haul kinds of sail. Close haul is when you can be most efficient, and it's what gets tested most rigorously for the helmsman test. So the helmsman test is really important because then you can sail in more wind conditions, but also that's when you can start bringing out guests. When you're sailing upwind of the close haul,
yeah, I just wasn't sure where, but luckily Bob had on his email, like,
what's the first element? What's the first thing that tells you you're on a close haul? That we've covered already. What's the definition of a close haul?
The wind is at 45 degrees.
Winds at 45 degrees from our front. So this is the boat, and that's the bow. I'm sitting on the bench. Boat's going that way. If I look forward, the wind will be coming from the front at a 45-degree angle going this way. The telltale is going to be flapping around like this, 45-degree angle. First element, 45 degrees into the wind. How do we want the sail adjusted? That's how you do it. You loosen up the main, let it luff, pull it in until it stops luffing. What do we call that? Verge of the luff. So the second element of a good close haul is that your sail is at the verge of the luff. As I mentioned, this is hard to tell, but the other way to tell is at the back, you're going to see a right triangle. What do you expect that? So one of the solo test questions is, when you're in a close haul, what three things do you look for? These are the three things to look for. Now it happens that if you have any two of these, the third one will automatically be true, as long as your boat's in good shape. If the sail's in good shape, the boat's, nothing's broken. Then if you are heading 45 degrees into the wind and you look back and you see the right triangle at the stern, you will be more or less at the verge of a luff. Similarly, if you're a verge of a luff, you see the right triangle, then you're probably in a close haul. Actually, you have to be more or less in a close haul. That's the way boats are designed. Questions about that? So when you have these things, and the sail, you're pointing 45 degrees, verge of a luff looks kind of like this. If the wind is blowing too hard, then what's the boat going to do? It's going to start heeling. So in other words, if I'm here, I'm sailing that way, the wind is blowing hard, and the boat will start to tip sideways. So heeling is just called tipping sideways. So another question on the solo test is, what do you do if the boat starts heeling too much? The first thing to do is to hike out. And that means to just sit up on the side of the boat and lean out if you're comfortable doing that. To put extra weight on that side. So that will help flowing up, flatten out the boat. If that's not enough, and the boat's still heeling too much, either for your comfort or when you heel too much, the boat actually starts slowing down, then you have to slow down a bit. You have to take the power out of the sail a bit. So there are two ways to depower the sail. You're going along here, you're in the close haul, the wind's a bit too strong or you're too light and the boat's heeling too much. You've hiked out and the boat's still heeling too much. You can let the sail out and that lets the wind slide off and that depowers the boat. Then the boat will flatten out. So first thing you can do is hike out. Second thing is to let the main sheet out, to let the sail out. Now, there's another way to turn the sail. Let's say I need to get the sail to go from here to here, or here to here. There's another way to do it. I can just turn the whole boat. That also has the effect of pointing the sail more into the wind. So that's where we use these terms, bearing off and heading up. If I need to turn the boat so it points more to the wind, what do we call it? Heading up. And how do we do that? Yeah, tiller towards the sail. And that will slow you down. So that's the third way to slow down going. If you're heeling too much. Any questions?
So the sail, is it actually fixed? Is it actually?
Yes. So the sail is attached to the mast, but that rotates. So it goes back and forth. You let the sail go, if I'm looking from the top of here. If I want the sail to go that way, I let the main sheet out. That's the rope, the line that's attached to the mainsail. It's going to be red. If I want the sail to move this way, I pull in that line, and that pulls the sail in toward me. Does that make sense? Does that answer your question?